Beneath the scenic cliffs of California's Palos Verdes Peninsula, the ground is slowly betraying everything built upon it. Entire neighborhoods inch toward the ocean, not by inches of erosion, but by the quiet, unstoppable movement of a massive landslide system that never truly stops sliding. Most people standing on these scenic cliffs have no idea they are living atop one of the largest active landslides in North America, a geological giant quietly preparing its next move. What if this creeping motion suddenly accelerated? What if thousands of tons of earth tore free in a single violent collapse and plunged into the Pacific? If this happens, this beloved stretch of coastline would become the epicenter of a devastating tsunami. This is not a fictional doomsday scenario. It is a scientifically plausible future rooted in real data, real movement, and real danger. Every storm, every earthquake tremor, every rise in sea level adds new strain to an already fragile system, pushing Palos Verdes closer to a breaking point no one can predict, but everyone should understand. Today, let's explore the ongoing landslide crisis in Palos Verdes and the growing risk of a massive collapse that could trigger a tsunami along California's coast. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The Palos Verdes Peninsula, a dramatic headland rising above the Pacific just south of Los Angeles, appears at first glance like a symbol of permanence. Its rugged cliffs, luxury homes, and manicured roads suggest stability, prosperity, and solid ground. Yet, what looks like a tranquil coastal paradise is, in reality, a massive body of unstable earth slowly sliding toward the sea. For decades, geologists have warned that Palos Verdes is not simply experiencing isolated slope failures, but rather an ongoing interconnected landslide crisis involving vast portions of the peninsula. Unlike sudden rockfalls or isolated mudslides, this crisis is defined by slow but relentless ground movement spanning miles, subtly deforming roads, cracking foundations, and warping utility lines. In some areas, the land has been moving for over a century, and signs now suggest that the system may be approaching a more dangerous phase. The instability of Palos Verdes is not a modern phenomenon. The peninsula sits atop a prehistoric landslide complex that formed thousands of years ago when large sections of coastal sediment collapsed under gravity and seismic stress. Over time, vegetation and development concealed the scars, giving the illusion of safe terrain. The most notorious of these zones is the Portuguese Bend landslide complex, one of the largest continuously moving landslides in the continental United States. First formally identified in the 1950s after construction destabilized the area, this massive slide zone covers several square kilometers and continues to creep seaward at variable speeds. At times, the movement is slow and subtle. At others, it accelerates dramatically, especially following heavy rains. In recent years, movement rates in certain sections have increased to several feet per year, tearing apart pavement, splitting sidewalks, and rendering roads such as Palos Verdes Drive South barely usable. This is not merely coastal erosion or surface slumping. It is the reactivation of a geological giant that never truly fell asleep. The underlying rock of Palos Verdes is composed primarily of soft sedimentary formations, including shale, siltstone, and clay-rich marine deposits. These materials are inherently weak compared to harder igneous or metamorphic rock, and are highly susceptible to failure when saturated with water. Clay layers beneath the surface act like a lubricated slip plane. When rainwater infiltrates the ground, it reduces friction and increases pore water pressure, creating ideal conditions for mass movement. The interface between these weak layers and more competent rock forms a natural sliding surface that allows large sections of land to detach and move downhill. Compounding this weakness is the steep coastal topography. Over millennia, wave action has undercut the base of the cliffs, removing support and allowing gravity to do the rest. The result is a slope system already predisposed to collapse, even without human interference. Then there is the Palos Verdes Fault, which runs offshore and is seismically active, though less publicized than the San Andreas Fault. A strong earthquake along the fault, could both trigger landslide acceleration and initiate a direct collapse event. This dual hazard scenario, landslide plus earthquake, dramatically increases the complexity and risk profile of the region. Ground shaking weakens slope material, destabilizes pore structures, and may provide the precise impulse needed to cause rapid failure. In recent years, the landslide crisis has intensified. Heavy winter storms have caused dramatic increases in movement rates. Areas that once moved inches per year are now shifting by feet. Satellite monitoring techniques such as INSAR have revealed consistent deformation across a broad swath of the peninsula. Instead of a single slide plane, Palos Verdes is behaving like a network of interconnected moving masses, creeping seaward in complex patterns. Urban development has dramatically intensified this natural instability. Since the mid-20th century, the peninsula has been extensively modified with roads, houses, golf courses, gardens, and infrastructure. Irrigation systems, leaking pipes, swimming pools, and stormwater runoff have introduced persistent moisture into the ground, further weakening already unstable strata. Construction added both weight and disturbance to the slopes. In several cases, grading and excavation remove stabilizing material from lower slopes, effectively destabilizing upper regions. Attempts to stabilize the land through retaining walls and surface drainage systems have often been overwhelmed or rendered ineffective over time. What was once a natural, slowly adjusting landscape has become an overburdened system pushed closer and closer to structural failure. While slow movement dominates public perception, the true danger lies in the potential for sudden failure. Large landslides often behave like loaded springs. Stress builds gradually until a threshold is exceeded, at which point movement becomes rapid and uncontrollable. A significant trigger could include prolonged rainfall, a major earthquake along nearby fault systems, or structural failure within the sliding mass itself. If a critical volume of land were to suddenly detach and collapse into the ocean, the consequences would extend far beyond local property damage. In a worst-case event, a large section of the coastal bluff would break loose and plunge into the Pacific in a matter of seconds. The sudden displacement of massive volumes of water would create a powerful surge, generating a landslide-induced tsunami. Unlike tectonic tsunamis caused by undersea earthquakes, landslide tsunamis are abrupt, chaotic, and intensely localized. They can reach devastating heights near the source and strike with virtually no warning. Such a wave could impact large stretches of Southern California's coastline, hitting Redondo Beach, Manhattan Beach, Long Beach, and even the Port of Los Angeles. The first wave would likely arrive within minutes, leaving little time for evacuation. While such an event would not affect the entire Pacific Basin, it could rank among Southern California's most destructive coastal disasters. The future of the Palos Verdes Peninsula will not be defined by a single moment, but by a slow tightening of geological tension that grows more dangerous with time. Scientists do not predict an exact date for a catastrophic collapse, but they do agree on one crucial point. The conditions that drive instability are intensifying, not improving. Each passing year adds new stress to a landscape already approaching its limits. Climate change will play a decisive role in shaping what comes next. Stronger storms and heavier rainfall mean more water saturating the fragile clay layers beneath the surface, further weakening the slopes and increasing internal pressure. Rising sea levels will accelerate cliff erosion at the base of the peninsula, stripping away natural support and making large-scale failure more likely. These forces do not reset with time, they accumulate. The most probable scenario is not sudden annihilation, but a progression of increasingly severe slide events. Portions of the coastline may become uninhabitable. Critical infrastructure could face permanent disruption. Entire neighborhoods may be forced to retreat as the land continues its slow journey toward the ocean. Yet, alongside this gradual decay lies the ever-present risk of something far more abrupt: a massive, rapid collapse capable of displacing huge volumes of water and generating a destructive tsunami. Palos Verdes is entering a phase where uncertainty replaces stability. The creeping movement visible today may be only a prelude to sharper, more violent transformations. What emerges in the coming decades could redefine this coastline forever, whether through steady retreat or sudden catastrophe. The land is signaling change, and the future will be shaped by how humanity responds to this looming disaster.